So now that we've been able to test out our basic sprite system infrastructure, let's revisit it. There's only one last piece of functionality that we need in place to call it complete, and that is the damage texture. We've talked about how with the sprite system, basically we have a sprite sheet mode inside the sprite sheet itself, and that mode says, hey, this texture right here can be a damageable texture, or it's not a damageable texture, depending on how that mode is set. Well, if it is a damageable texture, we know that in the textures array, we have two textures stored. And so far, we've only seen one texture. That's the texture that we load in. What about the other texture? Where's that come from? In this video, we're going to be revisiting the sprite sheet class, and we're going to be creating a make damage texture method. That's right, make damage texture. We're going to be procedurally generating a texture in this video, and then we'll simply turn around and make sure that the damage texture that is generated is stored in the second element of our textures array in each of the sprite sheets that get created if that sprite sheet is of damageable type. Okay, so Logan, with that, I'll go ahead and hand it over to you.
All right, let's get started. Let's turn our attention to the sprite sheet class. And it is inside of sprite sheet that we will be writing this make damage texture method. As a matter of fact, just a quick word on it, we're going to be making it static because I'm viewing make damage texture almost like a utility method. It's almost like if we, for some reason, had a texture creation subproject, we would delegate it off to that. Here inside of Spacefighter, there is no other place in which we use utility methods like this, and the texture being used is of direct interest to Spritesheet, and so that's where it's going to live, is inside of Spritesheet.
Yeah, it makes sense to me.
But the method is, of course, going to be static because this is something to be used on creation and on loading of a texture. So it's not going to be something different or unique to any instance of the sprite
and
sheet.
it'll be private as well because only the sprite sheet class needs to use it.
That's another good point, and we're only using it from within, actually only from within setTexture.
Yep.
So let's begin this. Let's put down a method, static. We're going to have a return type of texture 2D. The method is going to be called make damage texture, and we're going to take in two things. We're actually going to take in a texture 2D. We'll call that texture, and a graphics device. Reason we're taking in a graphics device is, as we're running this method, we will need to create a new instance of texture 2D, and that operation requires a graphics device. Now, to give an explanation of what's going to happen, basically, make damage texture from a very outside level looks like it takes in a texture, it duplicates it, and returns the duplicate. Though in duplicating the texture is where we go in and modify all of the pixel information. So we get a duplicate that is going to be black and white in color and brightened. We're going to do a pseudo grayscale operation. I call it pseudo because it's a cheaper version of it. I'm only going to consider the red channel, and I'm going to apply that across all red, green, and blue. But I'm also going to take that resulting grayscale and brighten it considerably. I want to make an effect that is as though the texture is turning white in color, but I want to retain some of the definition. So there will be some grays for some of the darker areas of the texture. But with that in mind as the goal, let's start putting down some of the things that we'll need to go in and modify pixel data. I'm going to begin with a local variable that will allow me to track how many pixels I'm working with. And we'll call that pixel count. And pixel count is going to be the overall total pixels that we'll be working with given the current input texture. So that will be texture.width times texture.height. The next thing I'll need is an array in which to store the actual pixel data. I'm going to make the array type color because I'll be working with each individual pixel as a color. So we'll make a color array, and I'm going to call this array pixels. And I'm going to initialize this array to hold the total number of pixels that we will be working with. So I'll initialize it to new color array with number of pixels being pixel count. The next thing I'm going to do is I'm going to load all of the data from the texture into our pixels array. So we'll look at our texture and we'll tell it to get data, and the type is going to be color, and the the variable in which to place the data is pixels.
And we've covered all of this stuff.
Yes, and again, this should be very familiar because for a few different reasons, for collision reasons, and even when we were testing delegates, we've looked at doing operations like this.
That's right.
Well, now that we have all of our pixel data in a convenient, accessible array, let's loop through that array and access the information pixel by pixel. I'll start a for loop, and I'll hit tab twice to throw in tab completion. We can use I for the index variable, and the length is going to be the length, or the, number of pixels, given as pixels.length. Now, inside of each pixel, the operation we need to do is to get the value of the red channel, brighten it by a certain amount, make sure we clamp that brighten operation so we don't somehow overflow the byte of information we're allowed and wrap back around to a darker color, then turn around and take that new brightened information and assign that to red, green, and blue. With red, green, and blue being the same, we will now get a black and white picture. Then we can turn around and store that back in the current pixel. Let's begin with that value that's going to be used to brighten the pixels. I'm going to make a byte variable, and I'm going to call it offset. And I'm going to set offset to a value of 200. So where we have a range of 0 to 255 for our channel information, I'm actually going to brighten the channel by 200. So that's a significant amount of brightness. That means only things lower than, I guess, about the first 54, 55 units is going to remain. Everything else will be pure white. Now that we know how much we're going to offset by as we brighten, I'm going to make 3 more variables, a byte for red, green, and blue. So let's begin with red. So make a byte variable. We'll just call this variable r, and we'll set this equal to the result of math.min. I'll use min to accomplish our clamping function. And I want the min between the two values of our red plus our offset and 255. So that is, in order to gain red, we need to look into pixels, grab pixels sub I, grab the red channel out of that, and add our offset. Now, the key here is that this may have wrapped back around, so we're going to check this against 255, and then whichever is less, we're going to keep. Meaning that if we have somehow wrapped around, then we should be clamped at a value of 255.
Hence the method name min.
Exactly. So I'm going to copy this line, paste it 2 more times so we can have green and blue.
What does min return?
Min is probably going to return a decimal, and that's probably not going to build very well. As a matter of fact, it's asking us to cast because 1 exists.
Yeah.
And as a matter of fact, I do need to cast, and I'm going to cast over to byte explicitly before storing that in any of the given variables. So if we cast, then everything works much better. Now that everything has been stored into their red, green, and blue components, we can go and set this as the pixel. We've read the data out, now we can set that back in for this current pixel. So pixels sub I equals new color, and we'll initialize this color with a red, green, and blue value of R, G, and B. Now for the alpha information, I'm going to preserve whatever the original alpha was. So I'm simply going to feed in the unmodified value of pixel sub I dot A for the alpha value. So now we have this all assigned back into pixels. Now we have a modified array of pixels, but we need to take that data from the array and put it back into a usable texture 2D. As a matter of fact, since the whole operation involves making a new texture 2D to return, we need to make that texture. So I'm going to make a texture 2D variable that I'm going to call outTexture. I'm going to set outTexture equal to a new instance of texture 2D. The first parameter needed is a graphics device, which we're having passed in as a parameter. We need a width and a height. I'm going to use the dimensions of the original texture, texture.width and texture.height. We need a number of levels to use in association with mapping. I'm only going to specify 1. And our texture usage is going to be texture usage dot none, because I'm not worried about any of the mapping or possible optimization implications there. We'll just use this as a standard pixel by pixel set of information. And looking here, let me see, there's one more parameter. It's just screen wraps inside of the tooltip. We need to specify a surface format, and I'm going to give a surface format of color, which makes sense as we're actually using the type color to adjust individual pixels. So with this new texture 2D, we can retrieve the data out of our pixels array and put that into outTexture. We'll do this by running outTexture dot set data. We'll be setting data of type color, and that data will come from the pixels variable. Now that we have out texture set up and all of the data written into it, now we can simply return it. So we'll return out texture, and that should wrap up the method. So now if we build, there are no errors, so it should be ready for use.
There you go.
So,
keep in mind how Logan's using the offset right there. You could always create a quickly controllable offset back over in the config class if you wanted to.
that's true.
You could with each sprite sheet back over in the sprite sheet. Well, we're in the sprite sheet class now. You could have it take in a brightness so that each particular sprite sheet that gets sent in could have a very specific brightness level, if you want. I just want to make sure that our viewers are thinking outside the box. There's a lot of different things that can be done here.
You could play with the algorithm design and optimize it a little bit. Because red, green, and blue are going to be the same value, there's no reason you couldn't initialize the color by using red, red, and red, or even just calling that value.
Absolutely.
Just throwing that out there, because I'm sure there are further optimizations that could be done. But the key here is that this is only being run when configuration is initialized. So if there is any slowdown caused by this, it's caused only at load time.
That's right.
So I'm not worried about how efficient or inefficient this may be. I'm just looking to get this effect accomplished. As a matter of fact, the separate red, green, and blue values do mean that you could tint it towards a certain color.
Mm-hmm.
If you were to increase red or blue, you could tint in that direction. So that way you wouldn't have to be stuck with just plain black and white.
Absolutely. All right, so let's go ahead and make use of this new method back over in set texture.
And I'm going to do that right after we set our element 0 in textures. So once we get that out of the way, now we're looking at setting that second element to represent the damage texture, or to set it to null to indicate that there isn't one. So I'm going to do a check, and I'm going to check our current sprite sheet mode and see whether or not we even need to make a damage texture. So we'll check mode, and if mode is equal to sprite sheet mode dot normal, then we know that we need to generate a damage texture. So if that's the case, then this dot textures sub 1 is going to be equal to make damage texture, and we'll feed in the texture given to us, meaning what you could read as the normal texture. We'll also pass along the graphics device, so that later we can make a new texture. And one quick spelling error there. I've replaced textures. Textures is the field of the overall sprite sheet. Texture
is the texture coming into set texture.
But
that's the one we want to send.
I'm sure that would have made the compiler nice and unhappy, though, because it is expecting a texture 2D, not a textures array.
Yeah.
Now, if our sprite batch mode was not set to normal, then that means it was probably set to no damage texture. That's the only other value we currently support. And if it was no damage texture, we don't, of course, want to waste time running make damage texture on something to throw away. We'll simply skip the running of make damage texture and set textures sub 1 to null to indicate that it is not set. So let's put in an else clause where this dot textures sub 1 is set to null. So no damage texture.
Excellent.
Let me bring this spacing back up. Let me build, make sure that everything is working. And now we need some way of testing this, making sure that it works, because without further game architecture, we don't have objects at all, much less objects that we can damage. So in order to gain access to this, I'm going to directly manipulate the texture index on our test sprite back in game. And the way I'm going to do that is I'll look at the update method, and I'll take our game times total seconds. I'll cast that over to an integer so I can watch that change as each individual second increments. I'll modulate that against 2 so we have a value that will flip back and forth between 0 and 1. 0 and 1 reference valid sprite sheet textures, so we'll feed that in, and then every other second we'll see the normal texture followed by the damage texture. To do that, I'll make an unsigned integer. So we'll say uint, and we'll call this value. I have no real further name for it. We'll make a value that's going to flip back and forth. So that value will be equal to the uint casted result of game time dot total game time dot total seconds. So we'll cast that double over to an unsigned integer. And once we have casted it, we'll multiply it against, or excuse me, we'll modulus it against 2. And this should give us a value that will flip back and forth 1 to 0 every second. After we obtain that value, I'll turn around and tell our test sprite to set its texture index equal to value. And then we still have our line to update, so we should retain animation. Now if we run, we should have every other second our asteroid changes to almost completely white. If you look towards the bottom, you can see some areas that are still a little bit dark, because there was a rather significant brightening of 200 in value.
Sure.
So only the darkest areas survive in any visible definition. Also, one last time I'll point out that this isn't a true grayscale. I'm relying on there being definition in the red channel. If your sprites in your specific game are for some reason entirely green, you'll of course need to make accommodations. Either use a true grayscale where you consider all values and average them, or just use the most relevant channel.
That's right.
But with that in place, that has proven that everything's working. It does give me an opportunity to point out what would happen if we change the texture over to no damage texture,
Okay.
and actually stress our settings a little bit. If you remember, in Sprite, we went out of our way up here in texture index to make sure that we don't put invalid values into it. Well, let's see what would happen if we change the asteroid sprite sheet and tell it that it should have no damage texture. If we went into its initialization and set a sprite sheet mode of no damage texture and ran, because of course no damage texture will result in texture sub 1 being set to null, and then we don't have anything to switch to. If we run and wait a few seconds, we see that nothing flips back and forth. So that means our checks are doing their thing. We can easily go in and simply specify that all of a sudden we just don't want that to have a damage texture, which is cool because we could have a damageable object if we wanted to, and it doesn't have to have a damage texture.
Very nice. All right. Well, with that concludes the video. That's everything that we set out to do in this video. And another nice thing is that concludes our sprite system that we're going to be using in Spacefighter.
I will note that I'm actually going to pull that back out because in the end I do want asteroids to show damage texture.
Sure.
So just point out that is getting changed back.
Exactly. Okay. Well, with that wraps up the video. Thanks a lot, guys.